Hello, this is TJ Montserrat and I will be talking about web architectures. The objectives of this video is how to define, to be able to learn how to define web architectures, differentiate web architectures from each other, and determine which web architecture to use given a requirement. So for web architectures, we usually have the simple client-server architecture where you have your client, which is, let's say, your computer, and then the server, which is the one that you are accessing. Um, so, and then there's the server architecture where the one requesting the data or anything to process the data is another server talking to another server. And then the monolithic setup is it's like the client server architecture, but the idea is that all of the things, which is let's say your web application server, as well as the database, is in one um, server rack or one server in essence, like in a one computer that is doing both the uh, database as well as the web application, among other things. Then there is the microservices where you have different um, small servers that acts as um, small web application servers or anything that would process a single function or a single responsibility, and they talk to each other to able to fulfill a request. Now, we also see a one-tiered architecture where in this one-tiered architecture, there's the client where you have your browser talks to a web application, and also the database are inside a single server. So in this setup, you have it's like the monolithic one, which we call one tiered, because you have both the web application and the database in one server. There's the two-tiered architecture, which has the web application that serves the HTML um, and the dynamic HTML um, or the dynamic page, depending on the request. And then you have the database on a different server. Now, n-tiered would have a load balancer or firewall in between the web applications, which are scalable. And then there's the database load balancer in between the web application and scalable database, which in with what it means is that it scales independently, both the web application and and the database. And then you also have a front end logic. Now, the thing is, I would just go back to the previous page, which is the two-tiered architecture. It can be a three-tier architecture where you have the logic as well on the client. Usually, when you use front-end frameworks to also um, change process the data on the browser before it goes back to the web application. And the web application becomes, instead of generating the page itself for every request, it just sends out the data. So it becomes like an API server. Now, for this n-tiered architecture, you use some sort of a middleman to process where the data should go. Um, like for this example, the load balancer firewall is responsible for the, how do I say this? I'm going to use a laser pointer. So this one is responsible for um, making sure that the data is sent to the correct uh, server, um, and can also be responsible for triggering setting up new application servers depending on the load. And this one is responsible for sending which database will accept the request or process the request. Now, for additional architecture examples, you have like the front end logic, which is served by a CDN or content delivery network for faster loading of the um, front end logic scripts. Then you have your load balancer firewall, and then your web application again, and then there's the database load balancer, um, which writes to a main writer database, and you have your read replica database to just get the updated data from here. So usually your read replica database are um, near your location so that it will be faster. While for atomicity, or what we mean by atomicity, or is that the data, when writing new data, there's only one database that is accepting it, so to make your data to have data integrity in essence. Then you have your microservices here, which is being um, communicate, or there is a communication line between the web applications and microservices, so that what this does is to um, what this web application do is to determine or be a front-facing um, server in essence, meaning the user can interact with this, and then for any background processes, all of these is done within the microservices, so that the user experience in front of the user is fast enough, because the web application only processes anything that requires the user to see the events. So when to use these kinds of setup? So you have your client server architecture. um, if we want to use a user interface and we want to offload some logic on the client but not put it fully on the client. So usually the client server architecture is not limited only on web applications. You can have like your um, client be a screen, and your server be the logic itself, or the small computer that is uh, delivering what is supposed to be on the screen. Um, so if you want to offload most of the logic on the server, you use the client server architecture. Now, for server architecture, this is using third-party APIs that requires the server to talk to each other. So let's say you have your computer here, your client, and then this one connects to a web application server, and it needs data from another server that, let's say, you do not own, or maybe you own it but it's of a different service. So this allows us to divide functionalities between the servers, divide responsibilities, functionalities. Now, for monolithic setup, the affordances is because it's easy to build on a small setup, and it's easy to maintain on small setups. Disadvantage, of course, is it's hard to maintain if it's really big, because you have a large code base, and hard to scale if the monolithic setup takes too long to boot up. So it cannot be scaled immediately, where you can instantiate another server that is a replica of this one and use it for traffic purposes. Now, when to use is for small and quick projects. Now, microservices, again, it allows us to divide responsibilities between small servers and can scale. So this one can scale independently of this one, depending if there is um, additional traffic and load here, but this doesn't need um, additional servers. So in essence, this one can scale up while the others is good. So in essence, you don't affect the whole architecture. The small services can sort of talk to each other. Or I mean, the small services can still talk to each other, and the small services can scale independently of each other. Now, of course, the disadvantage is hard to maintain when the architecture is big itself, and it's costly on first setup if it has a lot of small applications, like or small functionalities that you have separated with each other. So when to use it is good when you want to divide responsibilities to reuse those functionalities for other purposes outside your system. Now, one-tiered architecture, it's easy to set up, and but the disadvantage is it's not easily scalable, and there's no failover. So that means if your server, I mean the computer that houses the web application server and the database fails, then your whole web application is not available. Now, when to use this? For small size clientele or user base, like usually 100 is enough, and LAN-based services. So yeah, if it's like within a local network only. Now, for two-tiered architecture, the separation of web application and database is good because you can now have a separate web server and a separate database server for it, and you can scale this one up separately. Now, again, on basic setups, it still has no failover. So that means if your database server fails, of course, there will be no web application still. Now, when to use it? If you plan to separately scale database and web applications later, then this is a good starting point, cost-effective starting point, where if you don't need to scale up, then you have a working system. If you want to have two servers, just in case you need a failover, or you want to put another server for another particular location, then this is a good setup. Now, for n-tiered architecture, again, allows us to scale, but it's harder to maintain and more costly because you have a lot of additional components. But good, or when to use it if you have a larger user base and if you need failover. So that means if one fails, then the others can take over. Now, adding CDN, which is this one, the affordances ability to put static files like your scripts, JavaScripts, or your images near the user for lower latency. Latency meaning um, for faster download. And then disadvantages is harder to update new files if you update them without either using a different file name with hash or purge the cache. So if you don't update your file here, or you just updated the file but you didn't change the file name and you didn't purge the caching mechanism, it will still load the old file. So when to use? When using front-end frameworks or creating web apps. So web apps is something that is comparable to mobile apps because it looks like a mobile application but is served on the web. Now, adding load balancers in Firewall allows us to balance out the load for your web application. So like for this one, you can sort of, the load balancer decides which server can take in the request depending on the load. Now, you can also filter out requests via firewall policy. So that means you can have a more secured web application. But Again, harder to debug web application server problems if the load balancer is not configured properly. Now, when to use this? Again, if you have a large user base and if you want to protect your web applications from denial or distributed denial of service attacks. Now, adding automated scaling allows us to ability to spin up and shut down nodes, which is depending on parameters like CPU usage or memory usage of the particular node. Again, it's harder to debug if threshold is not set correctly or if spin up time is too long. And when to use is when you want to automate scaling and not manually do it. Again, need to use existing orchestration tools like Kubernetes or whatnot. Creating read replicas for database. Um, Read replicas allows us to ability to or allows us to scale the database itself and ability to read the data from a nearer database to your location. Again, the disadvantage is data that is updated might not exist immediately to read replicas because it will need to replicate the data to other databases, and of course it's costly. Now, when to use it? If you have a large data and user base. So that's it for the web app architectures, and see you on the next video.